Okay, so this is how I lecture. You should be able to see what is on the large screen, which I'm also recording for people that are not here today. So when you look at this, we start with chapter 13, and we assume that you have studied Chem 111 and that you remember everything from Chem 111. And this is a fallacy because students who take Chem 111 only need to get a C, so they may not have known everything from Chem 111, but yet I'm assuming you know everything perfectly. So I know that there's always that disconnect, so please do ask if you have any questions. The way that my packet is set up, you will see that I have homework written at the top of each chapter. And this is the homework in the textbook, and it is the page numbers. The page numbers are funny. Can I borrow your 111 book that you brought with you? The page numbers are funny because these custom books that they offer are kind of like a screen capture of the big book. So if you look at this, it'll say page number 187 here, but down here it says page 135. Whenever I'm talking about a page number on the packet, I'm talking about this number because that's the page number in my book that I set this up on. And then they basically photographed my book and stuck it in here and gave it a new page number. Okay, it's a custom book. But by doing that, they actually charge you a little bit less. So it saves some money and you don't have to buy the whole 2-semester book if you're not using it. So this is the homework that is assigned. This is not optional. Do this homework. It is not due on a particular day. You'll need to have it finished by the time you move on to the next chapter and before the test. Then in most sections, I may have some definitions here. Here I have gone ahead and filled in all these definitions because it's the first chapter and I never quite have time to get everything done the first couple of days and get into the chemistry with all that other stuff we had to talk about. So these are the definitions. Now, I do not give tests on definitions. So there won't be any test questions that say, what does miscible mean? But the vocabulary may include that. So it may say, ethanol is miscible with water and blah, 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 and ask some question. And if you don't know what miscible means, you won't understand the question. So you do need to know these vocabulary words, even though they will not be test questions. There's no vocabulary questions on the test. And if these are not already filled in, then I expect you to fill them in before you come to class, before we lecture on that chapter. So that's kind of how this works. Okay, we've already talked about a couple of these vocabulary words in laboratory. We talk about solutions, which is a homogeneous or homogeneous mixture. It can be atoms, ions, or molecules. When we talk about aqueous solutions, water is the solvent. The solute is what's being dissolved. The solvent is what's doing the dissolving. That should all be reviewed from Chem 111. We say things are miscible. That means they mix. When they are immiscible, they don't mix. And then the definitions we talked about in lab when we were making these solutions are these. If something is unsaturated, it has less than the equilibrium concentration. So we can look at 3 identical beakers, and you'll notice there is some distortion from the projection that makes my identical drawings not really look identical, right? So if we have 3 identical beakers, one is unsaturated, one is saturated, and one is supersaturated. In an unsaturated solution, as we add solute, it dissolves immediately, and what we will see is just the solvent. We don't see anything in there because I can keep adding solute and it will keep dissolving. In a saturated solution, I have added the equilibrium concentration, and I can add no more at equilibrium. So what happens is you'll see material sitting on the bottom of the beaker, and some is dissolving and some is precipitating at the same rate. And so you'll notice a saturated solution because to your eye you will see solid sitting on the bottom that is not dissolved. In a supersaturated solution, what you will see is that it looks just like an unsaturated solution. They look the same to the eye. But in this case, we have done something so that we have exceeded the equilibrium concentration. And by exceeding the equilibrium concentration, this is really quite unstable. And if you jar this or if you scratch the glass, all of a sudden you'll just get all of this material precipitating. And so it's very violent. You might have seen this. There are things on the market that you can buy for your house that are instant hot packs, and they have a solution in them. They're usually a heavy-duty plastic, and there's a little disc in there, and you click the disc, and all of a sudden things precipitate, and it gets really hot. Do you know what I'm talking about? Okay, if not, I can bring one. I'll bring it tomorrow and show you. I didn't think of pulling it out of my closet last night. So those are the saturated and supersaturated, and this is what we tried to make in lab. And tomorrow when we go to lab, we'll take a peek in that cupboard and see if your things are saturated or if you need to add more. And when we talk about concentration, we can use that two ways. We can say this is concentrated or this is dilute, just kind of a relative term, or we can use units that define concentration, and we're going to look at a lot of different units in class over the next couple of days. So, two factors contribute to the formation of solutions. The first is randomness and chaos. Nature's tendency is for randomness and chaos to increase. We call that entropy. We'll talk about that later. And that means that when we place things together, they will tend to mix. If we're mixing two gases, that is the only factor that we have to deal with. If we have liquids or liquids and solids, then the attraction of the solute and the solvent becomes important, and we have to look at how these things are attracted to each other. Now, hopefully you remember discussion of intermolecular attractions from Chem 111. I hope so, yes?